Hi everyone, welcome to my YouTube channel, and in this video we will talk about Leetcode problem 42. This problem is very popular and it is actually one of my favorite questions. So let's look at this problem. Here is the problem statement, and as usual I want you guys to pause this video for a second. Maybe try to come up with your own solutions before we look at my solution together. I'll be using this first example to illustrate how we can tackle this problem. So we are given this array. I think it is called height. So we are given an array called height, and we want to find out how much we can trap water. So in this case, for this array, we can trap how many blocks. So we can have six unit block, like you see this. So here, this is our, like, we can represent this array into this, and then we notice that we can fill this block, so that's 4, and we can fill this, the last block, so that's in total 6. So how should we solve this problem? If you go to this, say, discussion for this problem, I think I've seen like maybe 5 different ways of solving this problem. One of them was dynamic programming, another one was, I think it was 2 pointers, but for me I came up with stack. Let's see how we can solve this problem using stack. So we will be using the same height, and notice that we cannot trap water here, because, like, let's just pretend that all these, like, gray blocks are buildings. So for this first position, we notice that there is no building to its left side. So that means when you try to trap water, the water will spill over. So there is no way you can trap this water. So this is invalid. And for this one, say like this 2 in the middle, notice that we have buildings on both its left and right side. And then also here we can only trap 1 unit block of water. That's because this one, the height is 2, this one is 1, and we take the minimum, because if the height is 2, if you put, say, 2 blocks of water, then this water will spill over. So you cannot trap 2 unit blocks. So you can have only 1 block at maximum. So that's this one, and the same here. So how should we solve this problem? Well, as I mentioned, we will be using stack, and we will be iterating from position 0 all the way to the end. Initially our stack will be empty. If our stack is empty, then we have to append, we have to put the first, this first element here onto our stack. And in my stack I have 2 numbers. So here, if you notice, 1, 1. So let's look at this one. So say 3, 2. So the first coordinate that represents the position here. So 3, 2 represent this guy. And notice that the second coordinate represents the height. Here we have a height of 2 at position 3. So that's what this means. And we will be putting 0, 0 onto our stack. And then we will be keep building our stacks. So another question you have to ask for this problem is, well, when do you start popping our stack? And here, can you guys see this? Like, if you look at this problem carefully, when can we start, filling out this water? That's when we have a increasing sequence, right? So here we have an increasing sequence. Notice that here we have a 1. Here we have in this case it will be 2, 0 right here. So from here to here we have a decreasing sequence, right? We had height of 1, but then the next one we have a height of 0. Now at 3, 2, notice that we have a height of 2. So we have a, how should I say this? So if you take the calculus, we have a, inflection point, something like that. So we have when you have when slope changes, so from decreasing to increasing, then that's when we can pop this stack, and then we can maybe try to trap water. So that's the strategy behind this problem. And so in this case, we will be keep iterating our, on this height array, and then we will be putting, this coordinate onto our stack, and then we will be comparing the height. The current height, say for instance, suppose we are at position 3 and we notice that the height is 2, and this height is already bigger than the topmost number in our stack, since 2 is bigger than 0. So in this case, we will be popping 2 comma 0. We pop this guy, and then we'll be comparing the height. And notice that when we pop this guy, when we pop at 3 comma 2, when we are at position 3, we will pop 2 comma 0 first, and then we will be looking at 1 comma 1, right? So when at here, we are not just looking at this the water at position 2, we have to look at the water like the position 1, the height, right? Because like for position 2, we have to compare the height at position 3 and position 1. So that's something that we have to keep in mind. We have to look at this guy too. So that's the key idea behind this problem. And let's run this like pseudocode like through this visualization. Say we'll be starting from 0. Okay, so 0 comma 0 will be put into our stack. 1 comma 1 will be put into our stack. 2 comma 0 will be put into our stack, and then we are at 3 comma 1, and then we put it there. 3 comma 2, so 3 comma 2 is there, and then next one is 4 comma 1, that's here. 5 comma 0, we put it here. We have not yet popped our the stack, because notice that here we have a decreasing sequence 2 1 0. Now we are at 6 comma 1, right? At position 6 we have a height of 1, and we have a increasing sequence, right, from here to here, right from position 5 to position 6 we have an increasing sequence. Now then we have to pop this guy 5 comma 0, we pop this one, and then we will be looking at 4 comma 1. Now we notice that from this we have to take the minimum of like the height of this position 6 and position 4, right? So if you look at here, say right here, actually let's look at this one in so we have to take the minimum of these two height 6 and 4, that is 1, and then we are not done yet, right? We have to compare that to the height at position 5, because here like the example is simple, but you may have something like this, like you may have at position 6 we may have height of 3, at position 4 we may have height of 2, and at position 5 we may have height of 1. Now in this case, you cannot just compare height, you cannot just compare height at position 6 and 4 and then take the minimum, because they will give you 2, and then here at position 5 we have a height of 1. So you also have to subtract the height, whatever the minimum you get, from this height at position 5. So that's the key part. When you do that, you pop this one, so 5 comma 0 is gone, and then we have 4 comma 1 is still here. We do not pop this one yet, because notice that this height at position 1 is 1, and then the height at position 4 it is 1. So it is not strictly bigger than this, like the top most elements height in our stack. So in that case we put 6 comma 1 into our stack. So that's what's going on here. And then we look at the next one, 7 comma 3, right? Since 3 is bigger than 1, we pop this one, and then we look at the height at position 4. Notice that we don't have a position 5, because 5 comma 0 is popped, so that's gone. Now we'll be looking at 7 comma 3 and 4 comma 1. So that's from here 7 to 4 here, right? So that's this guy. Yep, and then you keep doing this, and that's what I mean by filling this out. We try to trap this water horizontally. So initially I thought about like filling this out, like trapping water vertically, but I couldn't really come up with it. So horizontally it made much more sense, I think. So anyway, that's for this problem, and So let's look at slightly more difficult example. So we have, like in this case, so we will be, so this is what's going on here. The first time we'll be, trapping water in this level, and then the next one we will be trapping water in this second level, and then the next time we will be trapping water in this level. So that's what's going on here. And yeah, so and this is the code for this problem, and you can see that this is what, like just about 10 lines of code. And so here we will be enumerating our nums variable. I think it is called height, but anyway, so we'll be iterating this given array, and then we have a while loop. So initially we do not have any number, any say data in our stack, so we will be appending the first guy, its position and its height into our stack. And the next time we see if we have an increasing sequence. If we have an increasing sequence, that's what it means by value strictly bigger than the topmost element's height in our stack. Then we pop the topmost guy, and then if we do that and then our stack is empty, then we break the while loop. Otherwise, we find out how much we can trap the water. That's by we first look at the minimum of, say, the left guy and then the right guy. So minimum of stack of -1. This is like the topmost element in our stack. And then we will be looking at the height, its height, and then the value is current position. So for instance, there will be this. So if we are at position 6, then we'll be looking at we will be first taking the minimum of the height of this guy and then this guy, right? So that's what's going on here. And then we have to subtract it from the previous height. That's the height of the element we just popped, and then we have to multiply that with the distance, and then we incremented our answer variable by this much current volume, and then we keep doing that until we hit the end of the number. So that's for this problem. And yeah, so let's look at the code for this and see what we get. Here is the code for this problem, exactly the same thing you just saw on my presentation. And so let's try to run this and see what we get. So yeah, so that's what we get for this problem. And I think I had exactly the same code, but I mean, this is Leetcode, so even if you run the same code, you can, it somehow, it gets slower by a factor of 2. But anyway, that's for this problem. If my video helps you guys understanding this problem, please give me thumbs up, and I will see you next time. Bye bye.